Okay, in this video we're going to go over problems 5 to 10 in the 2.5 section. So here are the problems right here, and let's use the next page to start problem 5. So, big picture thing, in each of these problems they're going to ask either for the maximum or the minimum, and then read the problem carefully to make sure that you are answering the question. So the way these differ from the first four is that here you have an equation to optimize, if you will, and then you have a constraint that you have to use to make your initial equation only one variable. So let's start on the next page. So here's number 5, and number 5 says Q equals x times y, and then x plus y equals 2, and you are asked to find the maximum of Q. So we want to find the max of Q. Okay, so first off, you can't deal with having two variables. So what I ended up doing was saying that y equals 2 minus x. And I did that by working with my constraint. So my Q now equals x times 2 minus x. Okay, so you could use the product rule to get your first derivative, but what I ended up doing, because this is a simple problem, I just distributed. If you do that, just do it carefully so that you don't make any, simple errors. Okay, so Q equals 2x minus x squared. So therefore Q prime equals 2 minus 2x. Set this equal to 0 to get your critical value, and I have 2 equals 2x, divide by 2, divide by 2, and that gives me x equals 1. Now I'm going to go ahead and take the second derivative, because they asked you to test it with a second derivative. So notice, the second derivative is always negative 2. That means that the function is always going to be concave down, which does give you my max. So I'm going to just do a quick little sign chart. I said just check on the second derivative. When I did that, I got a negative, and I would say at f prime prime of 1, that function is less than 0, which means it's concave down, which gives me a max. So here's your sign chart and your statement. Okay, so far I know that x equals 1. Remember, our goal is to find the max of Q. And I know that finding my x critical value will ensure I have a max. So if x equals 1, and I know that x plus y equals 2, then that means that y also equals 1. And then since Q is the product of x and y, and they're each 1, then my Q max is going to equal 1, and that completes that problem. So let's use the next slide to do the second problem. So they want me to find two positive numbers, x and y, that maximize Q. Okay, so Q in the second case, so this is problem 6, equals x squared times the y. Okay, and I also know that x plus y equals 2 once again. Now they want positive x's and y that lead to a max of Q. Okay, so they really just, the question is just to find the x and y's, and they have to be positive. Okay, so we have to kind of work the same way we did before. I would solve for your y, which is 2 minus x. Okay, so now Q equals x squared times 2 minus x. Okay, so here again you could do the product rule, or you can just multiply and then take the first derivative. So if you do that, I'm going to get this expression. So now take your first derivative, and I get 4x minus 3x squared. I went ahead and took my second derivative right away, and I got 4 minus 6x. So that second derivative is going to vary with the value of x. Okay, so setting my first derivative equal to 0, the first thing I'm going to do is factor out the x, and that gives me 4 minus 3x. So I have x is 0, which I cannot use because x is not a positive number then. And then I also have 4 equals 3x, so x equals 4/3. That is positive, and I can use that. Okay, so let's get our little sign chart. Here it is. This is 4/3. I just asked you to do a second derivative test. That means evaluate this at 4/3, and that's going to give me 4 minus 6 times 4/3. That's 2, which is 4 minus 8, which is less than 0. And since it's negative, it is going to give me a max. So I can say that f prime prime of 4/3 is less than 0, which gives me a concave down, which leads to a max. So here's my sign chart and my statement right there. Okay, so they really only want your x and y. So if my x is 4/3, then my y equals 2 minus 4/3, which is going to be, what, 2/3. So I have the following values, following solution, and I am done. They didn't ask me to figure out q, so I'm going to stop there. If I were to figure it out, I had gotten the q equals 32/27. Okay, but again, they didn't ask for that, so you're not required to solve for it. Okay, that brings us to problem number 7. Okay, and problem number 7 says, find the minimum of q equals x squared plus y squared if x plus y equals 6. Okay, so to find the minimum, I'm going to do the same thing that I did to find the maximum. I'm going to take the first derivative and then set it equal to 0 to get my critical values, and then test it to see whether I get a max or a min. So once again, I have a constraint right here, and I'm going to solve for my y. So y equals 6 minus x. So now my new and improved q is x squared plus, and I am going to, and I'm sorry, these should be both squared, x squared plus y squared. Yeah, so everything else is good. Okay, so this is going to be 6 minus x squared. Okay, so be careful, you have to FOIL that, okay? You can't just distribute the squared. So what I ended up doing was going ahead and just taking the first derivative. So 2x, and then plus 2 times 6 minus x to the first, and then don't forget the chain rule multiplies that whole thing by -1. So let's clean this up. So I have 2x, and then I have minus 2 times 6 minus x. Okay, so I'm going to still clean it up. 2x minus 12, careful here, plus 2x, and that's going to give me 4x minus 12, and then I take my second derivative, and I get a 4, which tells me right away that I'm going to have a minimum. Okay, so I have not solved yet for my critical value. Set that equal to 0, and what I get is x equals 3. Okay, so they don't want x or y, they just want the minimum, find the minimum of q. Okay, so let's just get a little sign chart going. So here's my 3. I did the second derivative test, so that means I have a min. So I can say f prime prime of 3 is greater than 0, which means it is concave up, which gives me a min. Okay, so there's your sign chart and your statement about your second derivative. If x is 3, then since x plus y equals 6, y has to be 3 also. And since I know q equals x squared plus y squared, and they're asking for the minimum q, that's going to be 3 squared plus another 3 squared, which is 9 plus 9, which is 18. And let me just make sure. Yep, and that is your final answer. So the minimum q is going to be 18. Okay, let's move on to question number 8. All right, so question number 8 is related to question number 7. It says, can there be a maximum for q equals x squared plus y squared? And so let's look back for just a second. And what I found is that the function is everywhere concave up. Okay, so if it's everywhere concave up, my original function has to look like this, all right? And due to the nature of a parabola, your endpoints are always increasing. So if my endpoints are always increasing, then I cannot, I never reach a max. So I can say that never reach a max, therefore a max cannot be identified. Okay, because it goes on and increases throughout the domain. So I can never say, yep, this is the max. So the answer, in a nutshell, is no, because of the nature of the shape. Okay, so moving on to the next one. So number 9, find the positive value of x and y that minimize s equals x plus y if xy equals 36. Okay, so let's do that on the next page. So let's write down what I have. I need to have positive values, and I want to minimize s equals x plus y. So in this situation, this is the function I'm going to minimize. My constraint is actually that xy equals 36, and I want positive values for x and y. That's what I have to find. Okay, so same procedure. So my s is going to be x plus, so I'm saying y equals 36 over x. So if y equals 36 over x, I can replace the y so that now I have everything in terms of x. I could do the quotient rule for the 36 over x when I take the derivative, but since my numerator is a constant, what I tend to do is just bring up the denominator as the -1 power. So now go ahead, in this form, you can take your derivative. 1, let me just change that, 1 minus 36x to the -2. Okay, so I'm going to go ahead and take my second derivative while I'm right here, and that's going to end up being positive, 72x to the -3. Okay, so that really is 72 over x cubed, and that will always be greater than 0 if x is greater than 0. So therefore, I have found the min, and let me just go back and check. Was I supposed to find the min? Yes, I was. So that's good. My second derivative tells me that whatever I found for a critical value will indeed minimize the function. And then my next thing I'm going to do is get my critical value. So a point to consider, having negative exponents is awesome for taking derivatives. It's not so good for getting critical values. So the first thing I'm going to do is I'm going to say that 1 equals 36 over x squared. Okay, so go back and take it out of that negative exponent form. So that tells me, if I do my cross products, that x squared equals 36. So therefore x equals plus and minus 6, but since I have to have positive values, I'm going to reject the negative and just say x has to equal 6. So here again, critical value. I have already done the second derivative, so I can say f prime prime of 6 is going to be greater than 0, which makes it concave up, which makes this a min. Okay, so I just have to find the x and y values. So I know that xy equals 36. If x is 6, so 6y equals 36. So therefore y equals 6. So I get x equals 6, and I get y equals 6. And if I wanted to figure out my s, they have not asked me. Oh, yes, they do. So I need to find the x and y, and also find this minimum value. So s is going to equal 12. So x is 6, y 6, s 12. Okay, we're going to go to problem 10, which I said was the most challenging. So let's set that one up. So for 10, it says find the positive values. So I need to find x, y, and z. And I need to find the q. And I want this to be a max. Okay, so now I know all of those things. All right, so let's set up our problem. So it says that q equals x, y, and z. Okay, and then I see that x plus y equals 1, and y plus z equals 2. Okay, so things that I noticed. Do you see how y is in both of these expressions? So that tells me that my best thing is to write x in terms of y and z in terms of y, because remember, I can only have one variable in the equation that I'm going to take a derivative of. Okay, so what I know is that y equals 1 minus, excuse me, not how do I do that? Let me back out again. Okay, what I know is that x equals 1 minus y, and I know that z equals 2 minus y. So I'm going to change my objective function so that it's all in y. So this is 1 minus y, this is y in the middle, and then z is going to be 2 minus y. Okay, so I have all of those. So let's go ahead and get my derivative started. First I'm going to distribute, so I have y minus y squared times 2 minus y. Now I could go ahead and do the product rule, but I think what I'm going to do is just FOIL this. And when I FOIL it, what I get, let me just turn to my correct page of notes here. Yes. Okay, when I FOIL it and clean it up, and I'll let you do that, you should be getting y cubed minus 3y squared plus 2y. Okay, so take that derivative, which is easy peasy, right? Okay, so that's what I'm getting. So I'm going to go ahead and take the second derivative, which is 6y minus 6. Okay, so what else do I know? Let me just look back for just a sec. Find the positive values. Okay, so these have to be positive. And since they're positive, I still have to get the value before I can figure out if my q prime prime will be positive or negative. Okay, so now I'm going to try to factor this. And within a few seconds, you should see that this is not factorable. So what you're going to do is do the... hold on one second. Okay, sorry. So you're going to do the quadratic formula. So when you do the quadratic formula, what you end up saying is negative b plus and minus the square root of b squared minus 4ac all over 2a. For those of you that might have forgotten the quadratic formula. So I end up getting, I'm just going to go like this, 6 plus and minus the square root of 36 minus 24 all over 6. So that was 6 plus and minus the square root of 12 over 6, which is 6 plus and minus 2 root 3 over 6, which gives me, for y, if I simplify this a little bit, I get 1 plus and minus root 3 over 3. So since I want a positive number, I want 1 plus root 3 over 3. Right, and that's going to end up giving me y, if I take it to the nearest tenth, is 1.6. So if y is 1.6, then x is 1 minus 1.6, which is negative 0.6, and z ends up being 0.4. Now this should immediately raise a red flag, because they told me they wanted x, y, and z to be all positive. So that's not going to work, is it? Because my x is negative. So let's try 1 minus root 3 over 3. That gives me about 0.4. If y is 0.4, that's going to be better, because that then tells me that x has to be 1 minus 0.4, which is 0.6, which is still positive. And then z is going to be 2 minus 0.4, which is going to be, what, 1.6. That is better. So these are the numbers I'm going to use, okay? I have to reject this because I don't have a positive x value. Okay, so I have these values. Let's now check 6 times 0.4 minus 6, so that's 2.4 minus 6. That will be negative, which will give me a max. So my sign chart is going to be for 0.4 if I take everything to the nearest tenth, because remember, the value I was solving for was y. This is going to be negative, so therefore I can say that since q prime prime of 0.4 is less than 0, I am concave down, which gives me a max. Now, q is the product of these three, so what is 0.4 times 1.6 times 0.6, and that gives me about 0.384, and I am good to go. Okay, so I hope you understand how I rejected the numbers I initially had. Y was positive in both cases, but it was too large to allow x to be positive as well, and that's why I have to go with this set of values instead. And I have a nice q, and I'm all set. So other landmines here, when you have this setup, you have some choices. You can get it to this step, and then you could do the product rule, or you can go ahead and FOIL it and then get to this step and then just do the power rule. Okay, your choice. You have to find that it's not factorable, and then you have to remember how to do the quadratic formula. Okay, so that's it. So that concludes this worksheet, and I hope you found that helpful.